Chapter 3, Section 3. We're going to be proving lines are parallel. We just got done with a lesson where we said lines were parallel, so what happens? Now we're going to say, if this happens, then lines are parallel. So we're going to use the converses, or you can kind of think of that as the opposites, the reverse, really, is a better way to say it, of the special angle relationships that we had before. Okay, let me grab my pen here. We'll get started. You can prove lines are parallel using the following reasons. There's a corresponding angles converse postulate. There's an alternate interior angles converse. There's an alternate exterior angles converse. There's a consecutive interior angles converse and consecutive exterior angles converse. Same siders is what these are. Okay, remember the consecutive is same side. Here, there. Okay. Now, all it is converses. We just reverse the way we say it. Instead of saying when two lines are parallel, then corresponding angles are congruent. Instead of saying when two lines are parallel, alternate interior angles are congruent, we're going to go and reverse that. If two lines are cut by a transversal so that a pair of corresponding angles are congruent, then the lines are parallel. So if angle 1 is congruent to angle 5 in our little picture we have, so we're talking about angle 1, and if we say it's congruent to angle 5, then we know that L is parallel to M. Okay. We can also do that for alternate interior angles. If we know that, let's say, angle 4 is congruent to angle 6, and those two lines are being cut by a transversal, so if angle 4 is congruent to angle 6, then L is parallel to M. And we can do it for all of the rest of them. If alternate exterior angles are congruent, so if we'd say 2 and 8, and we know those are congruent, so if angle 2 is congruent to angle 8, that's saying that alternate exterior angles are congruent. If that is the case, then we know for sure that line L is parallel to line M. If those types of relationships happen, then we know those lines are parallel. Now, when we talk about consecutive, the same sides, remember the S sounds, same sides are supplementary. So if two lines are cut by a transversal so that a pair of consecutive interior angles are congruent, then the lines are parallel is not the right thing, okay? That, not are congruent, we're going to mark that out. Are supplementary. So I guess we can leave the R, we just need to say supplementary. Somebody has a typo. We can do it here too. They have to be supplementary. Okay, so what we're going to say is if the measure of angle 3 plus the measure of angle 6 equals 180 degrees, then L is parallel to M. Because those ones are on the inside, angle 3 and angle 6. We could have said 4 and 5. They're both on the inside as well. We could also do the outside angles. We could say if angle 2 plus, measure of angle 2 plus the measure of angle 7 equals 180 degrees, then L is parallel. Don't know why I crossed that. L is parallel to M. Really, my parallel should be straight. Right and slanty there. There we go. Parallel to M. So those are the rules. Now we just have to apply them. So determine if L is parallel to M based on the information given in the diagram. If yes, state the converse that proves the lines are parallel. Well, here we have 63 and 63. Those are on different sides and they're on the outsides. So yes, They are parallel, and that's the alternate exterior converse. Okay? Because they're on the outside and they're on different sides. Now, angle 2 doesn't give us angle measure. It actually just gives us the symbol. It says this one is equal to that one. Those are in the same spot, different intersections. So this is going to be a yes. And this is going to be corresponding angles. Maybe a little angle symbol. Converse. Alternate exterior, I should have probably said angles. Converse. Now, this, number 3, let's look at these. Well, those are not the same, but they're also not corresponding. And they're not alternate exterior, but they are outside, and let's see what happens. Let's see. 132, 48. We're going to add them. 2 plus 8 is 10. 3, 4, 5. 3, 4, 5, 6, 7, 8. 8. Ooh, 180. They're supplementary. So yes, and that's going to be consecutive exterior angles converse. Converse goes the other direction. Says that since this is the case, then they're parallel. The regular theorems or postulates say they're parallel, so this happens. Okay? So let's look at number 4. They're telling us that these are congruent, and that's cool. Those are vertical angles, but it doesn't tell us anything about the angles in the other intersection. So this is going to be a no. We don't know for sure. They could be, but we don't know for sure. Number 5. These are already marked. They're on different sides. They're on the inside, so that's going to be a yes. That's alternate interior angles converse. And number 6, those are inside and on the same side. Let's see what happens. 125 and 65. 5 plus 5 is 10, 6, 7, 8, 9. That's 190. So that's going to be a no. Got to be 180. Got to be supplementary. So those are not parallel lines. They look like it from the picture. They sure look straight, like they're never going to touch, but they got to have the same rate of change, the same slope. All right. Given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. So the same deal. If we know this, now every time we start a new problem, it's new info. We don't use the info from the previous problem. So we've got a few lines in here. We got A, B, C, and D. So if 2 is congruent to 4, if 2 is congruent to 4, who does that prove? Well, this one's the cutter. These are the parallels. Those are corresponding places. So that means that C is parallel to D. That's what we got going on there. And that is because of the corresponding angles converse. So this is the core angles Okay, let's look at 5 and 10. Angle 5 and angle 10 are congruent. Those are alternate interior. This is the cutter. These are the 2 lines being cut. So now it's A is parallel to B, and that's alternate interior converse. Okay. M, measure of angle 1 and measure of angle 13. 1 is plus 13 makes 180. Those are consecutive exteriors for lines A and B. So we'd say A is parallel to B, and that's the consecutive exterior converse. All right, angle 1 is congruent to angle 14. Those are outsides. Oh, hello. Those are outsides. So that would be, let's see, this is the cutter, and those are the lines. So that's A is parallel to B, and those are alternate. Can't spell alternate. Hello. Those are on the outside. Okay, checking those out. Let's see, 14 and 15. So 14 and 15 add to 180. This is the cut. Those are the lines. So C and D on that one. And that's the consecutive interior con. Let's see, angle 11 and angle 16. Well, those are on the same intersection. It's vertical. It doesn't tell us about any other lines. So none. Okay. Now, take a pause. You try G through K. And we're back. Let's see what we get. Let's see, angle 4 and angle 15. Angle 4, angle 15. Different sides outside. So yes, that's going to be A parallel to B. That's alternate exterior converse. Okay. 10 and 12. Let's look at 10 and 12. Those are top rights of those intersections. So the cutter's B, that means C and D are going to, and that's corresponding angles converse on that one. Let's see, measure of angle 9 and 13. That's one intersection, tells us nothing. That's going to be none. We can't tell anybody from that info. Let's look at 2 and 7. Alternate interior. Cutter is A. Being cut is C and D. So C is parallel to D. And that's alternate interior angles. And C. Let's see. On the last one, let's do 6 and 11. 6 and 11. All right, these are different intersections, but 11's got these two lines, and 6 has got these two lines. It's not two lines being cut by one transversal, it's two different sets of lines. So that's not helpful. So that is a none. Can't actually do it. Okay. Given the following information, determine which lines, if any, are parallel. State the converse. Now this time we got 1, 2, 3 sets of lines. And we've got two different transversals. So let's do it a bit at a time. Let's see what 9 and 22. Here's 9 is supposed to be congruent to 22. Well, if we look at this as the cutter and those as the lines, that's alternate exterior, and that's Q and R. So Q is parallel to R, alternate exterior, converse. Okay. It helps to draw on them. 8 and 13 makes 180. Let's see, 8 and 13. Those are inside and same side of these two being cut by that one. So we know that P and Q are parallel. That's, nope, not alternate. Same side. That word is consecutive. Consecutive interior converse. 1 is congruent to 17. Angle 1. Where's 17? It's congruent to angle 17. This is the cutter. These are the lines. Maybe, if I can draw them there. Top left, top left. So, yes, we can say P is parallel to R. I don't know why I put a T on it. Corresponding. Converse. Okay. Let's look at D. Need my eraser real quick. I need the bigger eraser. Okay, I got it. Okay, 16 and 20. 16 and 20. These are the ones going. That's what's being cut. So Q is parallel to R. And that's alternate interior. Okay. Alternate interior converse. All right, give it a pause here. Try E through I, and let's see what you get. Okay, here we go. 2 and 22. Okay, here's 22. And 2 is up here. So we're looking at this line that line cut by that line. Those are on the same side of the same cutter. So, and they add to 180, so P is parallel to R, and that is consecutive exterior converse. 10 and 13. 10's here, 13's there. And it says they're congruent. These two lines being cut by that. Consecutive things being congruent is nothing. That actually doesn't help out at all. So that's going to be a none. Okay. Plus, they don't even look parallel. 3 and 22. 3's here, 22's there. Sometimes it helps to define it. Okay, so bottom right, that's corresponding. So yeah, we can say P is parallel to R. Corresponding. Angles converse. 5 and 15, let's give it a check. 5 is there. Where's 15 at? Right there. This one, that one. On the outside, different sides, so that's P is parallel to Q. Alternate exterior converse. Measure angle 2 and 16. Where's this? So we're looking at this and this, and that one's being cut this way, and this one's being cut that way. That's 4 lines. Diagonal intersections don't work, so that's actually going to be none. They kind of look like alternate interior, but they're not, because they're not on the same, they're not around the same cutting line. So that does not count. Okay. Last example. If 2 lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q and Q is parallel to R, then P is parallel to R. We can transfer through the things they have in common. They have this Q in common, and that links them together. And so P is parallel to R. So if A is parallel to C, then state which other lines are parallel and why. Okay? So we're saying A is parallel to C. So we're saying A is parallel to C. So we can mark that. Okay, then what else do we know is parallel? We don't have any angle data on A, but if we can say that A is to B or B is to C, then we know A is to the other as well. So let's see. What do we got here? What do we got here? What do we got here? Okay. Says that's 84 degrees. It's 84. That's 96. So what's the other side of 96? So we have this little situation right here that we can figure out supplementary. So let's see, 180 minus 96. I'll make that a 7. 10 minus 6 is 4. 17 minus 9 is 84. That's 84. So if we go with this cutter and these 2 lines, correspondingly, we know that B is parallel to C, is the corresponding angles converse. Okay, so we know that, oops, I'm deleting my arrow here. We know that this is the case. And if that's the case, we know that A is parallel to B. And the reason that we know that is what is called the transitive property. Okay, the transitive property transfers the parallelness or the equalness from one set of things to another set of things. So since P is parallel to Q and Q is parallel to R, we can transfer through the Q's that P is also parallel to R. Now, let's see if we can make any more stuff. We can't go C to D because, well, maybe correspondingly, let's see. What's 180 minus 62? 10 minus 2 is 8. 7 minus 6 is 1. 1. This is 118. Those are not parallel. So we can't say C to D, so we can't say A to D and B to D. So only those. Okay, just these two. And that's pretty much all we got for this section. Next section, we're going to add in algebra.